Welcome. The purpose of this video lecture is to talk about what the material that we call magma actually is. Most people think of magma as melted rock beneath the surface of the earth, which it is, so that's a pretty good definition. However, if we start thinking about magma in a more physical way, melted rock is really only part of the story. Most real magmas are actually mixtures of three things: melted rock, which I'm just drawing as a nice little circle droplet here, crystals, which are going to be solids with some crystalline structure, and gases, which that's supposed to just be a gas bubble. So melted rock, crystals, and gas. These three things comprise magma. Different minerals, those crystals, melt at different temperatures. So when real rocks begin to melt, some minerals will melt at lower temperatures and or pressures than other minerals. Here in the diagram, we start out with a rock. It's 100% solid. And of course, the rock is composed of minerals. As some of these crystals begin to melt, the rock becomes a magma. So from here on, we have magma. As we continue through the diagram, more and more crystals are melting, and so we have more and more percentage of melt in our magma, all the way up until we have 100% melt, 100% liquid. Conversely, we could start out by having 100% liquid rock, 100% melt, and we could let that cool down, in which case crystals would begin to form, and as it gets cooler and cooler, more and more crystals are forming until finally we have an igneous rock, which is 100% solid. Now, the longer this process takes, the larger the final mineral grains are going to be. This enables us to tell the difference between volcanic rocks, which cool rapidly at the surface, resulting in very small crystals, and plutonic rocks, which cool much more slowly inside of the earth, resulting in very big crystals that we can see with our naked eye. And every single little color here that you can see is indeed a different mineral. Here is what that volcanic rock looks like under a microscope. We can see that it still does have crystals, it's just that you need a microscope to be able to see them. Okay, back to this idea of melting. There is something else you need to know. It turns out that on planet Earth, pressure temperature conditions that result in 100% of the minerals melting, well, those conditions just don't exist. So in the real world, all magmas are going to have at least a few solids in them. And that's not all. In addition to the melt, shown here in red, and the solids, shown in black, magma is also going to contain gases, which are the bubbles here, the little white bubbles. At high pressures, these gases are completely absorbed in the melt, which is why we can't see any bubbles down in this magma chamber. This idea that gases can be dissolved in liquids is something you're probably more familiar with in the realm of carbonated beverages. For example, CO2 is dissolved in an unopened bottle of soda due to the high pressures inside of the soda bottle. However, as pressures decrease towards the surface of the Earth, the gases inside of our magma will exsolve from the magma, just meaning they create these bubbles here. And suddenly you have gas existing as a gas phase inside of that magma overall. The exact same thing happens when you open your can of soda. This suddenly releases the pressure on the mixture below, and the CO2 bubbles will appear, and they will then rise up to the surface because they are in fact less dense than the liquid which they are within. And it's these gas bubbles which get bigger as pressure on them decreases as they get closer to the surface. And it's these bubbles that make some erupting magmas explosive. So as it turns out, magma isn't just underground melted rock. It is underground melted rock with solids and gases inside of it. Another way of thinking about this is that instead of thinking of magma as a liquid, try thinking of it as more of a mush. A mush that, when it cools down, forms igneous rocks. This concludes our Magma What Is It video lecture. See you next time.